And let's follow with the conference. John Nielsen-Gammon is a professor in the Department of Atmospheric Science at Texas A&M University and the Texas State climatologist. He's here today to talk about a new kind of drought. All yours, John.
Thank you. Also, I hate teams, but that's a separate matter. And I think a lot of what I'm going to say is it was covered by Brianna. I wasn't able to catch her talk because I was transitioning from one location to another to get to a computer that worked. But I think we'll talk about the same thing in different ways, and so I'll just sort of go through this fairly quickly so we stay on schedule. So the average daily maximum temperature from middle of June to middle of September was the hottest on record for most of the state of Texas, as well as southern Louisiana, southern Mississippi, and you can find similar things all the way from the Oregon coast to Florida. So we weren't especially unique in that regard. And it also ranked driest on record in a few locations, but it was consistently among the 10 driest summers on record. The exception being some of the low rolling plains regions and places that were affected by Tropical Storm Harold that brought limited relief to some areas. To take a look at how things developed, I just wanted to show you an example from San Antonio. This is a plot of cumulative precipitation for the year. The brown line is normal. The green is what actually happened. And it was a sudden onset drought. The precipitation basically flatlined starting in early June and only gradually been recovering. If we compare that from the beginning of June to the other driest years, it was among the driest on record. It wasn't the absolute driest. There were a few that were dry, and it's persisted. So we're still sort of among the top 5 driest for that period in San Antonio. But as you've heard, the thing that really kicked things off was the heat. This is a plot of the annual temperatures for San Antonio this year. The orange band is the normal range. Top of the red is the record highs. The bottom of the blues is the record lows. And the vertical blue lines go from the high temperature of the day to the low temperature of the day in 2023. And weather tends to be pretty erratic during the winter and spring, but summertime really stabilized. And this year it stabilized in relatively hot conditions. You can see during this period, starting in about 8th or 9th of June, there was only one day where the temperature actually dropped below normal for the nighttime temperature. And even at that, the average temperature was above normal. And the key to that development was the heat dome that did capture the public's imagination. In the middle of June, we saw daily maximum temperatures and daily minimum temperatures increasing very rapidly during early June. And in response to that, the plants were getting lots of sunlight. There was lots of moisture in the ground from the precipitation that had happened earlier in the year. And one result of that was ridiculously high humidity. We had low temperatures around 80 degrees in much of the state, which is rather unusual, as you'll see in a moment. And then as time went on, the high temperatures increased and the low temperatures decreased, which is what you see in the atmosphere when the soils are drying out rapidly. Basically, a lot of the sun's energy can go into evaporating water from the ground or through transpiration from plants if there's plenty of moisture available. And that energy that goes into evaporation is energy that does not go into heating the ground or heating the plant surface and in turn heating the atmosphere. But as the ground dries out, as soil moisture gets depleted, there's less humidity in the air, so the minimum temperatures tend to drop a bit. And there's more energy from the sun available to heat the ground, and so the maximum temperatures rise a bit. And so that's the evolution we saw during the last 2 or 3 weeks of June. Very high temperatures due to the weather patterns, and then because those persisted, they cause the soils to dry out more rapidly than they normally do. And there does tend to be a bit of a soil moisture feedback in the South Central Plains during early summer, where if it starts out dry, it's going to stay dry because there's less moisture for thunderstorms. So that was probably a contributing factor to the persistence of this drought, although it certainly wasn't an absolute cause of it. I mentioned how unusual the high minimum temperatures were. This is a plot of the highest 7-day average minimum temperatures. And the winner by far is 2023. In San Antonio, it averaged over 79 degrees. Previous record was a little bit over 78 degrees. So it's quite a bit of an outlier in terms of that weather pattern that snuck in the middle of June to dry things out. Another indication of how rapidly the drought was triggered is a plot of the Palmer Modified Drought Index. The standard Palmer Index does things in sort of a funny way where you can't really detect the speed of onset of drought, but the modified index is more continuous. And you can see in South Texas, which is Climate Division 9, we've been through lots of droughts. 2005 and 6, 2008 and 9, the 2011 and the 15 drought, 2020, the 22 summer drought showing up worse in that region than 2023. But the thing I want to focus on is how rapidly the 2023 drought developed in the summertime after the spring rains that brought things almost to normal. That 1 month jump there is about 1.6 units in the drought index. And this plot is showing every 1 month change on the y-axis and the resulting monthly value of the index on the x-axis. So rapid onset drought would correspond to things in this quadrant where you have a large decline in the index from month to month because you're below zero over here, and that leads to a low value of the drought index. And that's the data point for June to July in 2023 in South Texas. So it was on the extreme envelope of how rapidly droughts can intensify. So I'm calling it a new kind of drought because, unfortunately, that sort of drought is the sort of thing that we expect to see going forward. I'm going to show a couple of slides from this paper from Kate Marvel and co-authors looking at the projections. And the projection of rainfall is very little change in Texas, although there's some uncertainty in that. The average model is saying rainfall will stay about the same, maybe decrease slightly. Most of the United States rainfall increases in the projections. But for soil moisture, it's projected to decrease everywhere, even where rainfall is projected to increase. And the reason for that is a couple of factors related to climate change. One is rainfall becomes more erratic because rainfall intensity increases and total amount doesn't increase. That means the rainfall is coming in shorter bursts, and that means more runoff and less soaking into the soil. Secondly, the higher temperatures lead to more rapid depletion of soil moisture when you get those gaps in the rainfall. And so the expectation, the message from this combination of predictions is that droughts are going to be becoming more flashy. They'll develop more quickly. Things will dry out more quickly when we have deficits. So to summarize, the drought we had during 2023 was effectively initiated by that heat dome, and that may have been a key cause of that. There's some folks under Liang and Dev at UT Austin. They're doing some simulation to test how much of a factor that may have been. I'll be interested to see what the results are of that. At any rate, the massive evapotranspiration in June, I don't have data on evapotranspiration rates, but I wouldn't be surprised at all if we had record ET for any time of year during that particular week in June. And that depleted the soil moisture. That contributed to reduction of precipitation and also increases of temperature because things were dry. And unfortunately, that's the story for the future. Future droughts are going to be hotter than past droughts because of because of the factors that we saw happening in 2023. The only difference is they won't be as unusual in the future because it won't take such an exceptional event to give us high temperatures and rapid depletion of soil moisture. The average temperatures are going to be working in that direction. Lastly, I just want to give a plug to the South Central Climate Resilience Forum, which is going to be held in the spring of 2024 in Dallas. I'll leave this slide up while I take questions, but the deadline for submitting an abstract or proposal for a workshop is today. You can go to the website for more information. So thank you for your attention. I'm sorry I'm an hour late with this one.
Thank you, John. We have some time for questions. Please raise your hands or write it in the Q&A. Jason?
Hey, John, Jason Clear. I was hoping you'd give us some great news, but from a rancher's perspective, but we need to know the true story. But yeah, I guess the question I had is on those temperatures, low temp, or the daily low temperatures. Where are those temperatures taken at that point in time? Because it seemed like here, the temperatures were higher than they were being reported, maybe at the ground level per se.
Yeah, they're normally measured at a height of about 4 or 5 feet above ground level, and that's the way they've always been measured. So it's a fairly consistent record.
Got you.
Yay?
Yeah, thanks, John. I wonder if you've done a similar analysis of the 2011 drought with the Palmer modified drought index as a function of time, where you looked at how the highs and the low temperatures during the day were converging, diverging. Did you do a similar analysis to see how similar or different 2011 was?
Well, we can look at the time series of 2011. And you can see that it did have fairly rapid decline. That was actually more in the middle of the spring when temperatures were starting to go up and things were drying out then. But I don't think there was a single extended event that occupied 1 or 2 weeks that caused the whole thing. It was more a matter of the plants started growing in the spring, and there was some moisture available to them, but they ran out quickly, and there wasn't any rain to replenish it. So, same sort of problem, but it developed over a longer period of time. And the minimum temperatures in 2011 were not as high as they were in 2023.
Right on. Thanks.
It wasn't just soil moisture, by the way, for minimum temperatures. The Gulf of Mexico was also record heat this past summer, and so the air coming in was unusually hot and humid just to start with.
Any other questions for John? Okay. Thank you, John.